So good evening, everyone. So we'll be talking about AI and its relevance. Why is AI so important for today's business and future business? Industry 4.0 and its compulsions. Why you have to modernize your manufacturing? Why do you have to modernize your business processes? This is one more thing, and now it's no more a nice to have; it's a compulsion. Then, of course, how is Next Tech helping? How can Next Step help MSMEs adopt these two technologies, and how are we organized, and what is that we have created as a capability under Next Tech to help companies adopt AI and Industry 4.0. Yeah, let's get on to the next slide, please. Okay, so my name is Arun Prasad. I have around 35 plus years of experience, industrial experience, out of which 25 plus years have been mainly as an entrepreneur. So my education background is I'm a mechanical engineer. So I'm a Six Sigma black belt. I have more than around 350 project experience. So I've worked, in many places in the world. So I have international work experience. And then I have specific experience also in this product development, especially technology product development, either as a product owner or as a product architect, or of course in handling various things. Yeah, Mr. Ravinder Singh, good evening. Welcome. Yeah. So this has been my profile. So plus I'm also a visiting scientist at Indian Statistical Institute. And that is a brief background, please. Yeah, let's get on to the next slide. So let's look at AI and its relevance. Why is it becoming a big buzzword? So we don't have to, nobody needs kind of an introduction. Now it's across everywhere. So everybody's buzzword is AI. Hence, what's actually happening in this area, and why is it relevant to? Is it relevant to India? If so, is it relevant to small businesses? And we'll try to explore a little bit about this enigma called as AI. Yes, please. So if you look at the definition of AI by Wikipedia, if you really look at it, it's saying that it's trying to perform or outperform or match sometimes. One is to match, the other one is to outperform human intelligence. By what? One is learning, just like even humans, right from a baby when it is born, even before it can talk, it does recognize maybe the voice of the mother, the face of the parents. It can start identifying sounds, etc. So the learning as rudimentary as that. And as the humans age, you see there are more cognitive capabilities, and so more learning actually happens. We create a situation for them to go to schools where they are totally focused on education and learning basically, and then slowly skills and stuff like that. And the sheer ability to do reasoning. Why is it actually happening? Trying to figure out those, because these are there only in intelligence. Humans have got this. There are of course other animals. You have dogs, you have dolphins, your crows, for example. All of them have got some reasoning capabilities, but humans have the best amongst all the living beings. So the machines get this ability to reason? So that means it's almost trying to match human intelligence, problem solving, perception. It means even kind of what is called as inference also, or coming out with an opinion. It's not just understanding something. It also has an ability to, have its own opinions, and of course leading to decision making. So all of this done by machines. Then it is termed as artificial intelligence, and this is a particular field of computer science. And then so It's becoming extremely popular these days. And I'll tell you why. What has changed in the last couple of years? Why is it considered as a very important aspect for businesses? Or the way humanity has changed. Just like how we say there is an era, pre-COVID era and post-COVID era. World has not remained the same. So many things have changed. So there is a pre-AI era and a post-AI era. So what is this, and what's going to happen? What are the changes that are expected, and how is it relevant? How can we actually join this and then make ourselves future ready, future business ready? That's the whole idea. Then, of course, if you look at the Oxford Dictionary definition, it is exhibit or simulate intelligent behavior. Who, what? Machines, basically. Okay. So they are trying again relating it to human intelligence by doing what? By using machine learning. So this is one thing that you need to keep. We'll try to understand what is this. To extrapolate from large collections of data. So one thing you will have to really understand is the moment we talk about AI, we are talking about data. If there is no data, then there is no AI. So the point here is how are we able to collect this data, and based on this data can we train the machines to do the remaining things, reasoning, problem solving, perception, blah, 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 extra, all of this, right? So this is in broad, a classical definition of artificial intelligence. Yes, please. So now, the moment we talk about artificial intelligence, of course, now the question is, what is natural intelligence? So if you look at the diagram out there, the center is the brain. Okay. So in this, let us talk about the most popular this year is human intelligence. So why are humans, smart and intelligent? Because they have a brain. So there is a brain in the center, but the brain needs signals basically. It needs inputs or it needs data. And this data is provided by 5 prominent sensories, as we call. One is smell. We have a nose through which we actually smell, and our brains are able to process the smell and then come back and say, yeah, it is a nice smell, it is a bad smell. Or you can identify objects just by smelling, for example, right? So now if you have, let us say, a flower like jasmine, even though it is pitch dark and you can't see anything, just by smelling you will be able to figure out that, yeah, this smell is coming out of, this has a jasmine fragrance, for example, something like that. So nose is one sensory which helps us, especially when it is coming down to food and stuff like that. If suppose there's a food which has gone bad, you can smell that, right? So smell is a very powerful sensory wherein it actually pulls in and the signals are sent to the brain, and a lot of processing actually happens on the brain based on the signal of smell. The same way with regarding to hearing, we have ears, and we through the sound that is actually there, that becomes the signal, it goes to the brain. And similarly, vision, because through our eyes what we see, and hence that data goes to the brain. Similarly, by touch, whatever we touch, so that is one thing. And then taste, of course, through our tongue. So now, if you look at all of those particular things, the input is that actually gets in is, instantaneous. What we call as real time. That means when you get something in, the signal comes in, it travels very fast to the brain, and then it comes back for us to take a decision. For example, we are walking and then suddenly we see there is a pit in front. As soon as you see that there is a pit in front, that information is sent to the brain, processed, and then you come back and take a decision either to divert yourself or you jump that particular thing so that you don't fall into the pit. So the speed at which the processing, the senses, the signals are picked and then sent back and then it comes back, that is what is making human beings very, very powerful, basically. We consider ourselves as the strongest species on earth. And the big difference that it makes is our ability to think and stuff like that. So why am I telling you this? Yeah, let's go on to the next one. Now, artificial intelligence is all got to do something with, our natural intelligence. So now, if you see pictorially, there's a machine, and the machine bring in the capabilities as much like a human brain, and both of them put together becomes artificial intelligence. So animal intelligence is separate, naturally, intelligence, it's all part of natural intelligence. So when it comes down to machines, it is called an artificial intelligence. So if you try to mimic the same, it needs a brain, and brain is the place where processing actually happens. So majority of the times it is a computer or a controller or something like that, which has the ability to actually do certain things, process, and you have the signals, and then hence the intelligence can actually come, right? And the world is trying to match first human intelligence and then later go beyond human intelligence also, because your ability to process is actually going up and stuff like that. So if you go back maybe 40, 50 years, also you had some games, computer games, especially chess. So if you are the, it's a two-player game. So you're playing, you are one of the players, and the machine becomes the other player. So those days, even up till 10 years back, majority of the time humans used to win. Human is one of the players and the machine is on the other side. So humans are more intelligent. Bad. It is no more, because the machine has got the ability to learn. It is able to come back. By now it knows almost all the moves a human will make. So in today's world, it's extremely difficult to defeat a machine which has learned. So slowly you see, but it did not happen in one day. It has taken decades. It has constantly been learning. More and more people have played more and more data, and hence it has actually become smart. Yes, please. So now, typically again, the approach is to mimic human senses. I, you have now cameras basically. So yes, are we? Is it as powerful as a human eye? No, it is still not. It has got capabilities, but it is still far away. But now, majority of the times, cameras. That's what is actually happening. If you look at so many camera, even including face recognition, all of these are based on camera-based solutions. Basically, cameras have become smarter, the ability to do few things, etc. But still, it has not reached the sophistication of a human eye. But a lot of work is actually happening. This is what is called as computer vision. So billions of dollars of research is happening all across universities in the world and large companies. But very soon, there are some capabilities. You would have already seen people who are using Google Photos. Suddenly, it is doing some smart things. It is able to take a photograph and then it is able to come back, identify you. Facebook, you have got tagging and stuff like that. Based on your face recognition, it can go and identify. So things like that. So a lot of what do you call capabilities, but still way far from reaching the sophistication of a human system. Then you have the touch. Of course, what you see below there are some gloves. There are some distinct systems. For example, even gesture. If you're doing some gestures, there are certain things. For example, if you scroll on the phone, you do this touch screen, right? Yeah, actually, so it is touch, and there is something called as a touch screen. That's how there is an interface. You are communicating with the machine through touch, right? Through gestures. So a lot of work again is actually happening there, and that's where to reach that level of human sophistication, it's still long way to go. Same way with regarding to nose. Now, nose is very powerful, so you have a lot of sensors now to identify, especially now. If you see, one of the disappointment that we get out of public toilets is smell. It smells if it is not maintained properly. Okay, so what is actually required here is uh, these sensors are becoming powerful now. They can smell ammonia, they can smell methane, they can smell uric acid. So it's almost like working like a nose. And the moment it picks up, either it can flush the toilet or it can send information saying that, hey, this toilet needs to be maintained. So some kind of progress is actually happening. Yes, it's still far away from ability to, match the capabilities of human nose. Wherein in this case, if you look at it, dogs, for example, yeah, they say that it can smell something about a kilometer away. Same way, lions, for example, can smell something which is 5 kilometers away. Elephants can sense water or sense or smell water maybe around 10 kilometers away. So animals are extremely powerful in this, much more evolved and much more stronger. Their sensories are much more stronger than compared to human animals. Then, of course, the ear. We see even if something is pitch dark, we can still hear. So it is all of them need not work. The smartest is to work in tandem, but they also can work in isolation. For example, that's how if you look at it, if somebody is blind, uh, does this mean that they don't have intelligence? They do have intelligence, but it's constrained. At least the vision part is compromised. Similarly, somebody who is deaf and dumb, it's not that they are not intelligent, they're as intelligent, but those particular inputs are compromised basically. Same way with regarding to taste, you can actually look at this. Tongue is extremely powerful. There are certain businesses which are run on what is called as organoleptic, especially tea tasting, wine tasting. They're extremely well paid, and it's all based on the tongue and the ability to recognize different kind of flavors and stuff like that. So the point here is a lot of sensors, and today, sensors are becoming cheaper. They're becoming affordable, not like earlier days where it used to be very expensive to actually, have sensors around. The most popular was vibration sensors. Even now, if you look at it, the moment if there is an earthquake, suddenly somebody is able to come back and say, hey, there was an earthquake here. What is called as seismic. What are those? They are nothing but sensors. They are able to actually come back and look at this thing. So what are they doing? They are identifying vibrations and stuff like that. So the most evolved thing is vibration sensing. Okay? Humanity has done a lot of work on this, and even in industries, especially wherever there are rotating parts, the biggest problem here is, the imbalance there. And if you want to sense that imbalance, how do you measure imbalance? Through what is called as this vibration sensor. If the vibration is more, then it is imbalanced. If the vibration is less, that's how modern cars, if you look at it, if you take a Mercedes Benz or a BMW, even though it might be, let's say, diesel car, on the car, you won't even know that the engine is on. So silent. Why? How come? Earlier, if you look at some 10-year-old cars, 15-year-old cars, there's a lot of vibration. You'd get to know. If in a traffic light, if some car is next to you, just by hearing or understanding the noise or the vibration, you'll get to know that it is a diesel vehicle. But modern vehicles are near perfect, for example. How did they do? There again, technology which has helped us do balancing and some of those. Yes, please, let's go on. Yeah, basically, let's try to understand this animal called as artificial intelligence. I've tried to really make it simple so that we don't have all the fad away and then make it easy. See, artificial intelligence as a science, as we are talking about as computer science, is not something that has happened recently. It has been there for the last 40, 50 years. Okay? Wherein, of course, as usual, it was the universities which set up their laboratories and they started doing a lot of work on this, but they were very far away. Okay? So there were some initiatives that were there. And then artificial intelligence really became real powerful, where a subset of this called as machine learning, that science came in. And then suddenly you see it gave a lot of more purpose for this artificial intelligence. And more use cases or very focused work actually started happening. And this is the time when artificial intelligence started becoming more, just like I was telling you, a chess game. It was part of machine learning. So when machine learning algorithms actually came up and became popular, so small games and stuff like that started coming, where machine learning was getting adopted, and more research started happening, serious research. Then a subset of that is deep learning, right? Deep learning is something wherein it is 1 minute, please. Okay, so one of the things about deep learning is the ability to actually, do problem solving. Some of those particular things, rational thinking, coming out with opinions. All of those particular things came through deep learning, basically. Okay, so those algorithms actually made it much more purposeful, and a lot of industry adoptions did actually happen, right, around deep learning. Some algorithms about this is, for example, let me give you this example of Netflix. So you have two OTT platforms. One is YouTube, and the other one is Netflix. What is the difference between the two? Both of them have content, and then you can go subscribe. YouTube has got more wider this thing. This is more towards entertainment and stuff like that. But otherwise, if you look deeper, the difference is Netflix charges. They demand a premium. Okay, so now if you have a Netflix prescription, you are paying that on a monthly basis. YouTube has got the free version, and then you have an ad-free version. But still, they are not being able to compete with Netflix. Why? Because Netflix now has got an algorithm which is called as, um, uh, you know, um, okay, let me give you this. When you're looking at content, of course, you need internet for this, and you need a device. You're watching the content. Suppose your internet is less. Let's say you're in a train or in a bus, and then suddenly you're going through an area where there is a dip in internet bandwidth. And when that actually happens, both of them are behave differently. If you are looking at YouTube, what actually happens, if it is in an auto mode or a 4K resolution, it dips down, quality dips, and then the user experience gets bad. If you're watching a cricket match, suddenly it is so grainy you can't even see the ball, right? And once the internet bandwidth comes back to its normalcy, you can actually, the quality improves. This is how YouTube is actually approaching life towards, this content delivery. Whereas in Netflix, they have what is called as compression. Okay, so what they do is, once the internet is connected, irrespective of the quality of the internet, the this thing is compressed. The content is compressed and delivered. So now suddenly you see, if you have a user experience about the quality on Netflix, very rarely, of course, unless your total internet goes away, then you lose those. Otherwise, they, actually compress this and then have some kind of a storage, and then they are able to deliver this to you on a regular basis. Now that's how is a difference in quality basically. That was achieved because of deep learning algorithms. Okay. Then of course you have generative AI. This is what made the whole world different. It has made everybody, talk about AI, not necessarily only technologists. I think anybody, any human being today in any part of the world, even in villages, if you talk, they're all talking about AI. So it became a buzzword because of generative AI. That is another part of, a subset of the overall thing called as artificial intelligence. Now, how does it work? So it works on what is called as foundation models. Okay? So you can there see there two this thing. One is called as LLM, which is called as large language models. Okay. So what do they do? They have the ability to generate things, create things which were not there. In all the other models, there was nothing that you could actually do. You have needed data. Based on data, you used to classify, you used to compress, you were able to do those. But from a common man's perspective, this became very popular, like translation services, You can generate an image. You can now generate a video. That's what you see there. Those are called as deep fakes. Okay, so AI generated content, either audio or video, are called as deep fakes. The science or the technology behind this called, these are called as deep fakes, and then you can come back. Traditionally, you can create an image or an object, one by a camera which captures this image, or an artist who sketches this. These were the ways that content was created, especially photos and images and stuff like that. Now, suddenly, just by asking, giving a description, you could actually create an image without a camera or somebody sketching. That became very powerful, and people started associating this. You did not need skills to do this. All you need to do was tell what it wants, the machine, and the machine used to deliver. Now, with regarding to chatbots, what actually happened? So, if you look at what we are at least seeing in the last 15 years is majority of the engineering colleges, kids used to go to what is called as BPOs, business process outsourcing. They used to do tech support. They used to do marketing support. They used to do so many things like that. Now suddenly all those jobs are gone. Where did it disappear? Did it go to some other geography? Did India become expensive and hence they went to somewhere else? No, those jobs disappeared. Where did they go? Who replaced them? They were all replaced by machines. You can see that thing called as chatbots. Now, suddenly, dependency on people to do those particular jobs were taken away. How? Because generative AI has got the capability. This large language models, as we say, is extremely powerful, and you don't. And it is not just scientists or engineers who are actually using this. On one side, you have this. The common man is able to interact with this. It has almost become like a Google search engine. Today, majority of the youngsters, they have stopped or almost their usage of Google search is minimal. They've all got into this chat GPTs. Like that, there are many Gemini, you have Meta AI, then you have Grok. There are many of them. Indian related, there is something called as Perplexity AI. Yeah, there is one more thing called a Hanuman AI, which is again an Indic this thing where I was involved a little bit in creating those particular things. So now the idea, what I'm trying to say is the biggest change that we have seen the last couple of years where the buzzword has become AI is because of generative AI. And now the question is, can we monetize this? Can we start adopting this in industries? Not necessarily those large research-based industries, even SMEs. Can it actually come? Can we use these machines, smart machines, to replace? Because one of the biggest problems for an SME is your inability to attract talent, right? And even if you attract, retaining the talent is very difficult. So now what do you do? So do you, today it is almost like I can't do anything kind of a scenario. But just imagine if these machines can come in, it is as good as having smart employees within your organization which can do part of your processes. Now, suddenly what was a weakness has become a strength for you. And it is not dumb, it is very smart. And if the machine is good, it does not ask for holidays, it never falls sick, it can work 24 hours for you, right? So now, if you ask me, the most apt solution or the best that can actually happen to MSCs, SMEs is AI. Most relevant big companies, okay, for profit or something like that, they might say, I'm replacing it with machines. They still do have the money, they can attract talent. Whereas in small and medium enterprises, the biggest problem was attracting talent. So now just imagine if this can actually help you, you can become world. See, one of the things that we are seeing now, also why this becomes very important is India has become the fourth largest economy. Our GDP has crossed more than 4.2 trillion as on last published. This thing we are expected to almost more than 4.5. trillion dollars is the expected GDP growth by the end of this year, and we might actually beat Germany. We just bet to Japan, and then we can become the third largest economy. That's one part, and very soon we'll become a $5 trillion economy in the next couple of years. So the expected thing is 2027. So now if you look at it, what does that mean? What is that opportunity? Now with $1 trillion of increase in the GDP means lot of opportunity for business. Okay, where is the business going to come from? Parallelly, that is where Indian government is signing up free trade agreements with so many countries now, because all those will become markets, because you need that kind of market access if you want to become a $5 trillion economy. Now that in turn will tremendously open up opportunities. Now the question is, are we ready to grab that? Big companies are very, very well organized. They have money, they can attract talent, they can actually on a mission mode come back and adopt all of this technology and then organize themselves to get this business which is big. But what happens to the small enterprises? And this is where we lose. Because if you look at the ideation, the thought, the brilliance that we actually have on our entrepreneurship is extremely high. We can think out of the box, we can do so many things, but we don't have enablers to convert that into tangibles. And that's how. And there are so many other reasons. SMEs, next generation, you're not able to, your own kids or somebody, the owner's kids are not interested to come in. So there people are demotivated saying, why should I do all this? For whom will I do all this? Right? Even if they actually have, they are not able to scale. Now the opportunity is that if you don't grab, please remember, business will not go anywhere. Business will be harvested by somebody else. And if you look at, if you compare Indian small and medium enterprises versus, Chinese, if you look at a, what do you call, a smart watch, a smart ring, some of those wireless chargers, earphones, all this in India are made by large companies, okay, or at least medium-sized companies. Whereas in China, a micro industry with 8 to 10 people are able to actually produce this. Now, if we don't scale ourselves up and adopt all of this, somebody else will take that away. And the backbone here is, if as a country, if you have to win, you can't, small and medium enterprises have to play this game because they are the grassroots basically. And then their impact is huge with regarding to this thing. So it is important that this is an opportunity, it's a godsend. We should not be afraid now. Okay. The bigger we think, these are all not research projects I'm talking about. These are all reality now. You can adopt, technologies, like AI. You can have products basically that suddenly will give you, and these are smart products which actually ensures and there is no dependency. You are not working to your weakness. Please remember, your strength is your ability to have entrepreneurial abilities, your ability to have that, ideation process and stuff like that. Combine that with this real capability, and suddenly you see the world is at your door, right? And SMEs, and this is an opportunity. If you play this game right, guys, AI is more of a boon to the small and medium enterprise, startups and stuff like that, right? Yeah, let's go on to the next one. Yeah, if you look at technology adoption, the first line is again the AI, okay? The projected line, so if you see here 1960s, it's not new, almost 60 years ago, 60, 70 years. From then, if you see, the expected projection was like this, like how AI would become popular over time. Now, suddenly there was a machine learning, a lot of things actually happened, and you suddenly see, around the 2000s, between the 2000 and 2010, there was a sudden spike, And suddenly you see the adoption of AI became much more, the projection became much more better. Then later we have the deep learning. It actually again push it up a little bit, but you see the other curve, generative AI. Suddenly you see there's a huge jump and the expectation of AI. And this is, let me tell you, it can never go back to normal. As I was saying, a new era has started, a new world has started where everything has to have some kind of an intelligence basically. Human intelligence is not enough. You need to have human intelligence coupled with machine intelligence. And now suddenly you see it is a game changer. Now, for example, my son has done his PhD and in the same AI area, and he is in the US. Okay. Now, if you look at the game that can US play with regarding to this thing, they are totally dependent on external talent, especially Indians. Today, if you look at the US, if somebody working on artificial intelligence, this basic fundamental work, it's all because of Indians. Okay, when we can do for somebody else, can't we do for ourselves? Right? So now the question is, Europe cannot play this game. Europe can never become like how earlier they used to come back, they could do this, they could do that. But with regarding to AI adoption, they can't do this. There are only two major powers, and both of them are in Asia. One is China, which we know. They are much more organized than us, but we need to organize ourselves because we are growing at a very fast pace. And the free trade agreements that we are signing, every market will open up. Only thing is we'll have to have sophisticated products with us to cater to those particular markets, right? And we are in a unique position. And SMEs, if SMEs play this game, guys, I'm telling you, building $1 million businesses is not a problem at all. Like how internet made so many millionaires, okay, over 20 or 25 years. Now the projection is AI is going to make more millionaires out in the next 5 years itself. That's the potential, that's the business that is there. And let me tell you, nobody can beat the small and medium enterprise to approach product engineering for this. So suddenly you can actually go and grab this market, like how the Chinese companies are doing. Today, if you look at EVs, at one point of time, guys, were you able to imagine that in Germany, nobody could beat German cars? Nobody could beat a BMW. Nobody could beat a Mercedes Benz or a Volkswagen. They're all giants. You know who is actually selling in Germany today? It is a Chinese EVs. And Germans are so proud about their technology, they would never want to give this away. But look at it, German customers have started buying somebody else's technology. Things are changing. Europe is no more a center for innovation as much as the potential that we actually have in India. So I think AI cannot be ignored, should not be one from a national perspective. Of course, the other one is from wealth creation. Yeah? And I know small industries have struggled all their lives, right? They've all struggled for their lives, this thing, and then the amount of value that is required for your effort is not proportional. Here is an opportunity to make it disproportional. With little bit of effort, you will be able to do much more. So this is a grand opportunity for small and medium enterprises to actually play this big role. Actually, okay? Yeah, let's get on to that. Yeah. So typically, if you look at it, guys, if you can look at it from a system engineer's perspective, this is how it looks. Sensors, what do? They sense. They get the data, right? The moment the data is done, it needs to be processed somewhere, like in the brain, it needs to be processed. And the output typically becomes what is called as information, right? And this information means nothing unless it helps us to take decisions. And these decisions should lead us to some action. And all of this need to actually happen in real time. So the benefit of AI is right from the sensors picking up the signals till it results in some action is what is called as real time. Okay, and the benefit here, AI should do this. Systems used to do this. The whole idea was to convert data into action, but it used to take a lot of time. Now, typically, if you look at it, even today's management system, what does the first thing the owners of businesses or the CEOs or the executives in organizations, what do? The first thing that you will do is, how did we finish yesterday? How did business run? Did we finish this? This was the plan. So there is a day. So today you're talking about yesterday. So there is a lag. But very soon you will see everything will become real time. There is no lag between when you are assessing or reviewing versus when this actually happened. It is all in real time. And that is what is making this powerful. Because today, why? We have processing strength. Look at your phones, for example, your smartphones. The ability to process. And one of the best things that has actually happened to humanity, of course, from a business perspective, there are also downside, addiction to technology, blah, 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 etc. All of those are the downsides of it. The upside of this is you last mile connectivity, the ability, multitasking. Your phones are much more powerful than servers these days. You know, you have octa cores. That means 8 things can be done parallelly at the same time. And it's available with you. It's always with you. That changed a lot of things. That is enabling real time. Right now, with more things, smart. Now you have got smart glasses which have come in. You can engage with smart glasses. It can come back, tell you so many things. It has microphones which can tell you in your ear. You can see few things. Intelligence is built in. You can ask a question as to what you're saying. For example, let us say I'm meeting somebody. I remember his face, but I don't know his name. You know what? The smart glasses can actually tell you who this gentleman is. I can do a quick search on him through a voice command. Now just imagine. So now wearables are going to change the world it is. We are seeing smart glasses, smart rings, smart watch. Clothes are becoming smart based on, especially in sports. It is trying to come back and look at your sweat analysis and then tell you how much energy levels you have. And this information is actually available with the coach in real time. Who is tiring? Who needs to be replaced? You know, so the point that I'm trying to say here is, guys, this whole thing here is action that actually happens in real time. There is no gap between an event and an action. Event generates data, and then later something else has to actually happen with regarding to action. Now there is no gap at all. It's becoming almost real time, right? So the whole world is moving there. Hardware is getting upgraded, processors, you are getting GPUs, you have got quantum computing which is coming in, ability to crunch data in real time, smart devices, algorithms which are there, you have got the cloud, tremendous amount of capability of processing, right? All of these particular things are actually available. Yes. Does it overwhelm us? Yes. If we don't know how to organize ourselves to reap the benefit, then suddenly everything looks like a mountain. But we can strip that down, calmly look down, organize our thought, structure a product which can use many of those particular things which are actually required by the industry. And here, let me tell you about SMEs. The cost of customer acquisition. You spend so much time to get a customer. It's not easy. But are we getting the maximum value out of this customer who is available here? The least benefit here, or the only partial benefit of that, is taken by medium and small enterprises. Because there's no engagement model beyond that. We don't have technologies to engage the customer subsequently. So every time we acquire a customer, we get only partial value. We are not getting the full value. because we don't have anything to offer beyond basic things. So now, can we do this offer? Can we get more out of every customer? Can we sell them more? Can we add value to their businesses? Yes, it's all possible through AI now. Okay? Yes, let's get on. Yeah, basically, if you look at it, you see two diagrams there. One is cloud. Below is what is called as edge computing. So edge computing is at the device level itself, you have smartness. For example, now let's look at a normal camera. Normal camera is a dumb camera. What does it do? Its job is to take the feed, capture this feed. Okay, either you take an image, it takes the image, stores in some place. If it is asked to take a video, it takes a video and stores. Beyond that, it can't do anything at all. Capture the data and then store. Right? Now, if you want to do any processing, you'll have to send this data to the cloud where you have the servers, powerful servers, which can do all these algorithms, etc., and bring back that information. But because of all of this, it's not real time. Now, what is actually happening is the devices are becoming much more powerful where you can run some of these algorithms at your device level itself. Just imagine if there is a camera. See, now the camera that you're seeing me, it is actually smart. It can zoom in, it can zoom out. Depending on who is talking, it can actually zoom and zoom out. So such kind of capabilities are now available in smart camera. Just couple that with image processing capabilities, algorithms which can run at the camera side. If a terrorist or a pickpocket or somebody walks in front of the camera, if it can sense and then flag this information as somebody is actually undesirable element is actually around this, then you see how purposeful it can actually become. But today we don't have that capability. You still need human beings to watch that. Right? All systems today, there is a lag basically. Right? So now edge computing is making this much more powerful. That's how if you look at it, if you're keeping your eye on this, now chips that are being done, nanometer. So whatever is actually available today, if you see, very soon they are working on small devices, wearables, etc. 2 nanometers. By physics, it was almost impossible to actually pack so much amount of processing. It's nothing but transistors into 2 nanometers. But not only that, people are producing this and they're using this. So the ability to compute has increased and in small sizes. And hence the devices are becoming smaller. And that is what edge computing is. It is one science where hardware improvements to actually run these businesses. That is where deep learning or deep compression is actually helping. You can run all the same algorithm either on a big server or on a small place by compressing basically. That's what it is. So if you see this, there are so many algorithms here. Some are classification algorithm, data classification, regression, and this is used for forecasting, clustering, where you're trying to find affinity between two different things. For example, now let me give you this. Affinity here is if we talk about a retail store, okay, and the way the lanes, this thing aisles are there, where you actually go in. Now, any large format, you see there will be boards there saying that cleanliness products or that or this, and then you see that you go, and suppose you're looking for toothpaste, there is no surprise that very close to the toothpaste is a toothbrush, right? Why did they decide to keep both of them together? Because the probability that you buy a brush, you will buy a paste is very strong because of the affinity. You don't need too much of data analysis or crunching or any of those algorithms to come back, because by observation you will get to know. Pant and shirt need to be close together because the probability that when somebody buys a pant, they'll also buy a shirt. So that's how they keep two next to each other. Is that how it is? Is that what it is? No. When you have, for example, a typical store will have 30 lakh items, what is called SKUs. Now, how do you know what to keep next to each other? Beyond this, is there an affinity amongst these 30,000, 30 lakhs products so that we can keep next to each other? For example, it's beyond human comprehension. For example, they discovered through these algorithms that a first time father, okay, when he goes to a store to buy baby napkins, he also buys a beer. Where is the correlation between the two? It is way beyond humans' imagination where baby napkins and beer. We can't make that. But these algorithms will find out, right? So the point what I'm saying is lot of ability, science, these models, they're all, again, all these models are not something that was discovered yesterday. This has been in this thing for the last 25, 30 years. Their mathematics departments, computer science departments have been working on these labs to perfect this particular thing, right? So the point that I am trying to say, guys, is all this, we don't have to worry. It has reached a stage of maturity where we just have to adopt that. And back end, it can keep running, it can keep doing this, right? Yeah, let's get on to the next one. Yeah, basically information could be by way of signals, okay? Now, or it could be by way of alerts, which we already know. We keep getting notifications and stuff like that. Sometimes you get it by way of infographics, especially if you are using a smartphone, a smart watch, and then you're doing some walking. If you have come back and say, I'm going to walk 3 kilometers, the moment you finish 3 kilometers, you suddenly get a notification or an infographic. You took so much time, your heartbeat or vitals was this, and you covered this particular thing. It summarizes the information actually as an infographic. Sometimes a part of it's a graph is also a part of that. Sometimes scorecard, which comes back and tells you various different things. And signals are typically information. For example, let's look at this today. More and more machines are talking to each other. One simple example which happens every day is our smartphone with our Wi-Fi adapter, right? So Wi-Fi adapter, there is a wire which comes internet wire, and then it broadcasts signals basically, so that through Wi-Fi wirelessly the devices can actually do. So for which there is a key. First time when you do, that is how the handshake actually happens between your Wi-Fi adapter and your phones. So everybody who has got, maybe you have a laptop, you have that this, you have got a smart TV, you have got a smart, let us say, you know, safety security system. All of this can get connected to the internet through this Wi-Fi, right? So now, especially you have this smartphone, you are within the house, you don't even know they're already talking. You take it for granted. After some time, you don't even bother. You'll bother only when internet is not there. That's the time when you'll look for why it is not there, right? Till then, it does not happen. You go outside the range of this Wi-Fi adapter, communication breaks, signal is broken between the two, and then you come back home within the range, automatically they are connected. So you don't even know that consciously. It is like breathing. When we are breathing, we are not conscious at all, right? Similarly, here, they are connecting, talking to each other without you knowing. You don't even recognize after some time, it's a done deal. Only when somebody comes to your home and say, hey, can I give me Wi-Fi access? And that is the time when you pair, or rather try to ensure that these two things work. Same way with regarding to earphones, smartwatches, through Bluetooth you connect. And the moment you connect those particular things, there's a signal. Machines are talking to each other, right? Without our internet. Yes, first time we need to set it up, and then later it takes on. So this information from one machine becomes an input for some other machines, and they talk to each other. That's how through signals basically. Yeah. And in this case, a lot of radar, RFID technologies, all of these particular things actually use this. Yeah, let's get on to it. Now, of course, the moment an information is taken, it has to result in action. This we have been doing. Human beings, this is a nice, methodical approach towards decision making. And here in this case, I've articulated the 7 steps of decision making. The same thing the machine can actually do. All it needs is to understand that these are the 7 steps. And then once they understand, they keep doing this over and over again. So decision making can also actually happen. For example, if you're looking at a driverless car, you're driving and then you come to a traffic island and then the traffic light becomes red. Now the decision here is the car has to stop, right? Every time the color becomes red, how does it sense this? There are cameras. The camera will read that. We'll actually come back and keep telling whether it is red or green or is it orange. Based on those particular things, the car has to do certain actions. And this decision to stop, to go, to slow down, all of those particular things. Even, for example, they're so smart that if you're driving on a highway and it is 80 kilometers per hour speed, certain stretches they reduce it to, let us say, 60 kilometers per hour, your car automatically slows down. The decision it has taken because it has got certain signals saying that, hey, boss, this stretch is only 60 kilometers per hour. So the car automatically reduces its speed. So if you look at an AI vehicle or a driverless vehicle compared to a manned vehicle or a human driving a vehicle, the compliance is much higher. In fact, I have sat in what is called a Waymo. That's it used to be part of Google, but now it is not. It's a separate organization. They run these driverless cars in the US as taxi service. Very popular in California, very popular in Texas also. So I had a chance to sit in one in Austin. Wow, amazing. It is safe, it is secure, knows exactly what it will do, and it is following all the rules of the game, right? So now sophistication has actually reached this. Why? Because decision making, the machine is taking a decision. It's not human decision, right? In human beings, we already had that. We had what is called as cruise control. You put it on cruise control, it keeps going. But you have to intervene if the car in front is slowing down. You have to put your leg on the brake, get onto a manual mode and do this because it was not able to take decisions. It only had the ability to do this. Now ADAS, which is called as adaptive driving assistance system, is not only this, it is able to take decisions. Your car in the front slows down, correspondingly your car will slow down. Then it will sense around saying that, oh, next lane, nobody is there. Then it will overtake. It will change lanes safely. Now, where is the decision making coming in? Because the machine can take those particular decisions because it has to do. That is based on the 7 steps of decision. Yes, please. Then, of course, which leads to action. Some of those things I've already explained. So, if all this does not lead to action, then it is not worth it. It ultimately has to end up in action. And so that is where it has to result in an outcome. Okay. Yeah. Yeah. Here are some of the applications. Google Maps is a very powerful thing. Okay. Again, here, please remember, your phone is talking to the satellite directly through a sensor called as GPS. Okay, location services as it is called. Now, if you want to make this, why is it so powerful? It handshakes your mobile handshakes with the satellite 8 times every second. 8 times. That is the intensity at which the data keeps going up and down. And the satellite, please remember, is few kilometers away, up in the atmosphere. Right? That is the frequency at which data is moving, and hence it's able to give you in real time directions wherever you're going. You miss one particular turn, it is going to recalculate, reassess, and then come back and give you alternatives, basically. Right? Like that. We talked about so many things. Okay, chatbots, fraud detection, blah blah blah, etc. There are so many things which are there. And now you can add translation services, real time. You don't need to fret. You can now converse with two two people can converse in two different languages, but both of them will understand and will be able to communicate to each other. Real-time translation services. So now just imagine what happens to the world. Can you actually do business with foreign entities which are in two different languages? Of course, why not? Technology is being able. Today, in India, states are fighting over languages. Marathi versus Hindi, Tamil versus Hindi, Kannada versus Tamil, right? So you have all of those particular things. Just imagine if this is actually available. Now this problem is straight away solved. I have my smart glasses. I see something which I don't know. If I come back and say I want it in my local language, I want it in Kannada, and I am in Tamil Nadu. There is a board in Tamil. My glasses is able to tell me what is the street which is written there. I don't have to go and fight there and say, put it in Hindi, put it in English. We don't have to do that. Now, is that possible or is it a dream? Definitely not. It is doable. It's already there. See, for example, this is the glass I have is a smart glass. Okay, now let me do this. I can take a photograph by command. Okay, so just a minute, just warming up. Okay, hey Meta, take a photo. Hey Meta, take a photo. Did you see? The light went up here. You know what it did? It actually took a photograph. It has meta intelligence. I can ask this. Hey Meta, what is the temperature in Bangalore presently? Yeah, 80 degrees Fahrenheit. Of course, I can set it up to say in degrees centigrade also. So now at the same time, I can ask any question. If I see somebody, I can ask a question. Can you tell me who is this person? It goes into the social media, etc., looks for your photograph and then picks up a name and then tells me what your name is. All this is possible. It's reality. This is there. Now just imagine if SMEs can come out with products like this. We don't have to go and make smart glasses. There are so many people over there. All we need to do is take smart glasses, work with maybe a smartphone, blah, blah, blah. Put all of those particular things and have a solution. Can we do it? Definitely. Do we have the talent to do it? We have the talent to do it. So you see AI adoption will be the highest in small companies, from small companies. They will contribute more. It's no more those big companies which has to do that. Right? Yeah, let's get on to this. Yeah, if you look at the market size, just look at those numbers, guys. You can't ignore this. No businessman can ignore this. Look at this. By 2033, $3.5 trillion. The economy as big as maybe UK, right? That will be the opportunity for AI, and it's going to grow at 31%. Sure winner. In such kind of things, Gada, Goda, everybody will succeed because the market is going to grow in this economy. If it is growing at 31% annual growth or compounded annual growth, right? If you look at the other one, it is talking about 4.8 trillion in a decade's time. So this is up to stay. You have the capability. All we need is to organize ourselves. We are very good at ideation because we can identify opportunities. This is a skill that Indians have got. It's almost, let me tell you, from birth. But we need to monetize, harvest that idea into tangibles and then monetize this so that it can become revenue or earnings basically. Right? Yeah. Now, of course, what are the skills required? The skills required are in mathematics, science, computer science. Okay, you can see some of those things: statistics, probability, predictions, calculus, logic, blah blah blah, etc. All of this. Of course, you need to come back. What sensor? What will it sense? How does it sense? Physics, mechanics, cognitive learning, language processing. Okay, these are some of those particular skills that are actually required. So where do we get this? You don't have to worry. You don't have to worry. That is where next step. We will talk about that. Okay, which we are trying to enable small industries to adopt technologies, AI-based technologies, basically. So all of these things is what we bring to the table. Okay, we'll talk about that subsequently. Yes, please. Yeah, even the skill demand. We are already seeing, as I was telling you, explaining, BPO jobs are gone. They have lost their jobs to computers, chatbots. There are so many things that will change. They're saying 70% of the jobs that are required in 2026, 27, those jobs are not existing today. These are new skills. Old skills will not play. For example, somebody is doing coding. Suddenly, you know what? You can do what is called as low code applications. The AI will build, generate codes for you. Now, where will a traditional coder go? Same way, if something can actually be done, if a robot can replace some kind of jobs, earlier it was all you had to program it, set the rules, and the robot used to behave. Now the robot itself can become smart, just like driverless cars. It can start doing certain things, it can take decisions across a framework. If something is required reworking, it can actually straight away take and rework and solve the problem and bring it back. Instead of rejecting, there is a quality control person who has to reject it. Then somebody else will go take that up, rework, then again test it, find it okay, and then bring it back. Now, all of these things can be automated. Now, so the skill of even the engineers that we hire, the accountants that we are hiring, the way they do today, if there is an expenditure, you'll have to make a voucher related to which capital head, expense head. Somebody approves this, then it will get posted into the system. So it will go under expenditure. Tomorrow you want to do an analysis. How much did you spend on travel? How much did we spend on materials? How much did we spend on salaries? How much did we spend on, marketing and promotion? Today you need a lot of smart people to actually do this. Put it into the system, and the system will do. Just imagine if this can be done, where the data goes, you provide access to your, let us say, bank account. It pulls the data, categorizes the information, and in real time gives you a balance sheet every day morning if you want. Now, where will all these people go? Because those skills will not be useful going forward. Because all these are possible now. Because machines have started becoming smart. And for the small industries, it's a blessing. Why? Sheer difficult to get your talent. Talent acquisition is the biggest problem for SMEs. Yeah, replace that with a machine. Anyway, you are not taking away anybody's job. Nobody was there to do that job. So you found a method. What? You found a machine. It is coming back and doing this job. So the newer jobs and the older pre-AI, whatever were the skills, majority of them will get watered out. New set of skills will come up. Right? That's what the skill demand is talking about. Yes, please.